Okay, so this is problem number 8 from chapter 3. We have 120 volts connected in series with 4 ohms. Here we have an 18 ohm resistor connected in series with 3, which is connected in parallel with 3, which is in series with 6. And we need to find the power for each of, dissipated by each of the resistors. And we need to find the power delivered by the 120 volt source. And we need to show that power developed by this circuit is equal to the power dissipated. So let's get started. In order to find power, we need to find the current in each of the branch currents in this essential node here. So let's label this as V naught. To find that, we simply do node voltage at V naught. So this branch, we need to find this branch current, or those 3 branch currents. So we have V naught minus 120 over 4 ohms plus V naught over 18 plus V naught over 3 plus 6, which is 9. Those sum to 0. Essentially, it's KCL, Kirchhoff's laws, which says current into a node must equal current out of a node. Conservation of current. So we go V naught, take all the coefficients of the V naughts, and bring this to the other side of the equation. And when you do that calculation, sum that together, divide this, take this number divided by this number, you should arrive at V naught is equal to 72 volts. So now we have a value, 72 volts. Okay. Now we can use that to calculate the power. On this one, we need to take the branch current, and so for the P sub 4 ohm resistor, remember when we calculate, well, let's just calculate the current through that resistor, because that's going to be I squared R, and I is just 120 minus 72 over 4, and that's going to be squared times 4. This is just current squared. When you do that calculation, you should come up with, this is 576 watts. And power through the 18 ohm resistor, P18 ohms, is equal to V squared over R, which is 72 squared over 18, which is 288. On this one, we're going to have to calculate the current, the branch current, because we need to, the two options for calculating power is V squared over R. And the easiest way to do that, or I squared R. So the easiest way to do that is take the branch current and calculate through that. So we have that branch current is V naught over 3 plus 6, which is 72 over 9, which is 8 amps. So the power of the 3 ohm resistor is 8 amps squared times 3. And that is 192 watts. And power of the 6 ohm resistor is 8 amps squared times 6. And that is 384 watts. So we have 192 watts here and 384. And remember earlier when we were finding power through the 4 ohm, we calculated the current through that, and the current was 12 amps. So power of the 120 delivered by the 120 volts voltage source is just VI. That's just 120 times 12, which is 1440 watts. That's power delivered by the voltage source. So we want to show that power delivered is equal to power dissipated. Power consumed are consumed in the 4 resistors. Resistors always consume power. So power dissipated is going to be P of 4, power consumed by the 4 ohm resistor, power consumed by the 18 ohm resistor, power consumed by the 3 ohm resistor, and power consumed by the 6 ohm resistor. And that's going to be 576 plus 288 plus 192 plus 384. And that should give you 1440, proving that power developed is equal to power dissipated. And that's the answer.